Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a topic in mathematics, and of course this topic is going to assist us answer the question, what is the closest power, or what is the closest quantity to the power of 10 a particular measurement can be. Now often we find that there are some distances which we cannot be able to do an approximation or do a physical measurement, of course which will require us to use our intuitive or maybe some existing laws which have been established in order to try and make a measurement. So that is one of the aspects that we're going to consider here in our discussion about order of magnitude. So we're going to look at different procedures in which we can be able to express this order of magnitude. And of course, where it is significant, we're going to mention this video so that it can be able to assist us in trying to find an answer to some problem set that may entail order of magnitude. So thank you and welcome. So in that case, the concept of order of magnitude is of course a concept that complements the broader topic of measurement that we often learn in maths and sciences. So in this case, the order of magnitude is going to assist us to answer the question, what is the closest power of 10 to a given number? So when we're going to learn, we're trying to learn, so we're going to have a small recap, of course, of some of the concepts that we need in order to understand this concept of order of magnitude. So in this case, when we are trying to express numbers in scientific notation, we write numbers, for instance, if it's 360,000 in that order. So we can express this number in scientific notation by writing 3.6 times 10. This is 1, 2, 3, 4, 5. So in this case, we're going to write 3.6 times 10 to the power 5. So in this case, we have two different aspects of this particular number, which is the answer that we have given. Of course, there are two areas whereby we have an indices, which is 10, or an exponent, which is 10 raised to the power 5. And then we have got a second, or the first part of it, which of course has two parts, which is an integer part, and this is a decimal, that is or a fractional part, which is a decimal fraction. It's a decimal fraction. And therefore this whole aspect, and this is, of course, as we have said, this can make an exponent, or in another way that we can express, so long as we understand or we bring out the concept that it's a power of 10. So in that case, of course, writing the numbers in scientific notation gives us this particular format. And we can see that the format is made up of an integer value and the decimal fraction, and then there's an exponent. So in this case, this particular set of writing numbers is very convenient because, of course, it first of all makes calculations and maybe trying to find the values of numbers convenient. In that, working with very large numbers, of course, brings its own way of inconvenience. So in this way, of course, the writing numbers in scientific notation will be able to assist us try to find the different values, the differences in values of numbers. So the order of magnitude comes in a way that it is trying to assist us, of course, as I have said, answer the question, what is the closest power of 10 to a given number? So in this case, the order of magnitude stresses on this second exponent part of this number that has been expressed in scientific notation. And we're going to see that at specific values, maybe from 1 to 10, and this is the midway, which is 5. Of course, there are values which are going to be below this, they're going to be treated in a specific way, and values above 10 are going to be treated, values above 5 are going to be treated in a specific way. So we're going to see that the concept of order of magnitude takes into account this part of a scientific notation, which is written like that, into account, and then it also takes part into account the second part, which is an exponent of a number which is expressed in scientific notation. Now, given a number like, let's just try to give an example. So having discussed that, so given a number like, let's just give an example. This is 202.47 times 10 raised to power 8 kilometers. So this order of magnitude concept is used to approximate quantities which of course are very large, like the distance between the Earth and the Sun. It is not physically possible for us to measure, so therefore we're going to give an approximation. So order of magnitude is an approximation. So therefore, given the number, and we're being requested to find the order of magnitude of this particular number, as we have said, we can see that the number has got an integer which is 2. This is an integer, as I said, and this is a decimal fraction part, and then we have got an exponent. So when we're trying to express this number in its order of magnitude, we're going to ignore the fractional part. We're going to ignore the fractional part, that is, and if the integer part, which is 2, is less than 5, the order of magnitude of the power of 10 is given, is with the order of magnitude, of course, is the power of the 10 given with the number. So in this case, if we're going to consider this a condition for us to try and convert this specific number in its order of magnitude, in a sense that if a number maybe which is an integer x is greater than 5, therefore we're going to increase. There are two conditions, so which means the first condition is so that if this number, which is an integer part of the number, is less than 5, the order of magnitude is the power of the quantity which is given, of course, which is 10 raised to power 8. So therefore, in expressing this number in order of magnitude, these two, looking at the range between 1 and 10, is more closer to 1 than 10. So therefore, for those numbers which are less than 5 and closer to 1, we maintain this order of magnitude, and therefore this can be expressed as 1 times 10 raised to power 8 kilometers as the order of magnitude of this specific number, which is 2.47. So in this case, this simply means that if this number is, we just ignore the decimal fraction part. If this number, which is an integer, is less than 5, or is less than 5, in that case, we're going to assume it's 1, and then this order of magnitude is going to be just regarded as 1 times 10 raised to power 8 kilometers as the order of magnitude of this specific number. Suppose we have a case whereby the order of magnitude of a different number, like, just to give an example. So suppose we have a number like, this is 8.35 times 10 raised to power 4. That is can be kilometers, miles, etc. It's a quantity, those are the units of a quantity. Therefore, in this case, we said that we can just look at the integer part of that number, and it is greater than 5. Therefore, we're going to give it as an approximation of a number which is 10. So if it's less than 5, we give it 1. If it's more than 5, we give it 10. So it is going to be, therefore, implying 10 times 10 raised to power 4. This is miles. This is its order of magnitude. So in this case, we're going to find that this quantity is going to be 5 miles, and this will make up the order of magnitude of this specific number. So therefore, in trying to look at this case, this applies for both the positive and negative power. Suppose this is 10 raised to power x, and there's another one which is 10 negative x. This is positive and negative x. This particular concept applies to both of them, so long as we're just expressing them in orders of magnitude. So therefore, suppose we had a number like, which has a negative exponent. Let's try to look at an example. So suppose we have a number like, this is 5.74 times 10 negative 9 kilometers. This one expressed in its order of magnitude will be, of course, we have said this is greater than 5, so therefore it's going to be represented as 10. So implying 10 times 10 negative 9 kilometers, which can be written as 10 negative 8 kilometers. So this is the order of magnitude of this specific number that we have given. So there are different prefixes that we use to represent different quantities as far as the powers of 10 are concerned. Of course, we are familiar with the kilogram, which is representing 10 to the power 3. The micro, which is representing 10 negative 6. The femto, representing 10 negative 12, etc. So in this case, for the positive part and the negative part of this specific derivatives of the quantities, or the powers of 10, as far as measurement is concerned, we have specific prefixes that we use to denote the quantities. And therefore, in this case, if we are trying to compare the two different quantities and we are required to find maybe the size in order of magnitude of one quantity against another one, we can be able to express this one using the following. So suppose we have one, this is a femtogram, which is to the power, of course, this is a femto, given an impression that a femtogram is 10 negative 12. No, this is 10 to power 15, 10 to power negative 15. This refers to a femtogram. So that's a correction for that case. So in this case, if it's one femtogram, which is 10 negative 15, of course, grams, we're going to have and we have another quantity, which is 1 micro. Of course, this is going to be 10 negative 6. This is a microgram, so 10 negative 6 grams. So if we are we're asked to compare the two quantities in order of magnitude, we're going to use, of course, and just use this quantity in order to represent that one. So we're going to use this order in order to find that one. So suppose we are asked that how many orders of magnitude in micrograms, how many orders of magnitude is a microgram greater than 1 femtogram. So we're going to compare and use the larger quantities of the two in order to find what is the difference, or how many times one of the quantities can be able to be expressed in terms of another. So you do this as by dividing the largest quantity by the smallest quantity. So in this case, if it's a negative exponent, then this one is going to be the largest quantity divided by the smallest quantity, which is going to give us 10 to the power of 9. And therefore, this is going to make our order of magnitude. Therefore, we're going to express this one as, this is 1 microgram, is 9 orders of magnitude greater than, just doing a comparison between the two, 1 and 1 femtogram. So in this case, we are going to use those derivations. And basically, when we're trying to do maybe just a comparison like this, ensure that we confirm the quantities of these specific prefixes that we're trying to see, and the denotations are okay. So for that case, we're going to see that this is how we are going to do. So you take one, suppose somebody asks you, this is a 1 gram, which is equals 1,000, 1 kilogram, sorry for that, 1 kilogram is equals 1,000 grams. So in this case, we are going to be asked, you compare it with the microgram. So you'll be able to find basic representations for those two specific quantities, and you express them using this particular concept whereby the larger value is being divided by the smallest quantity in order to obtain the order of magnitude. So in this case, of course, we're going to find different ways in which we are going to express these orders of magnitude. But basically, remember that we have talked about the powers of 10, and there are two different, there are three different areas that we've talked about. Of course, as I said, that it is easier for us to do calculations by expressing numbers in scientific notation. And then we have this number, which is an integer and a decimal fraction. And then this is an exponent. And these two specific parts, which is an integer and an exponent, play a very important role in expressing numbers in order of magnitude. If this number is less than 5, it's going to be 1 times the power which is expressed there. Now it's going to be retained. But if this number is less than 5, greater than 5, therefore we are going to consider this number to be 10 times the power which has been expressed, and therefore we'll see that there is an increase in power. So in this case, we're going to say that it's 6 orders of magnitude, 5 orders of magnitude, etc. And given two quantities of maybe derived unit like the one that we have given, just confirm that the conversion that you are using for the units, of course, is accurate, and then you can be able to express by dividing the larger quantity over the smaller quantity. And then the exponent that you obtain will be the order. Suppose it is x, then it will be the order of magnitude. But one of the larger quantity is greater than the smaller quantity. So in that case, that is the basic information that we had to get from here. And I hope we have understood on how we can be able to express order of magnitude given different quantities. So this is going to assist us, of course, in trying to find approximations of quantities which are very large, especially in measurement, and maybe trying to find distances and maybe other quantities that need to be expressed in terms of order of magnitude. So that is it for today, guys. So bye. God bless you.